Lesson 1. Simplifying Radical Expressions.
In this video, we have presented three conditions to identify if the radical expression is in its simplest form. But take note that we will only be discussing conditions 1 and 3. First is the radicand has no factor that is a power of the index.
Secondly, the radical does not contain a fraction, or the denominator of the expression does not contain a fraction. Lastly, the index of a radical is in the lowest possible form.
Let us start with condition 1. Again, this case connotes that the radicand has no factor that is a power of the index. This case can be solved using two methods. All the examples that are presented here will be solved using the two methods. The first example is the square root of 45. The first step for the first method is to find the factors of the radicand which are perfect nth powers. In this case, it is square root of 9 and square root of 5. The next step is to use the product property and then to simplify the perfect nth powers, which is 9, which will then become 3. This will then result to 3 square root of 5. The second method is somewhat similar to the first. The first step is to determine the index used. Always remember that if there is no index, it is automatically 2. The next step is to factor out the radicand. The factors of 45 are 9 and 5. 9 can still be factored into 3 and 3. Remember that we took note of the index. We now get two similar factors since the index is 2. Take note that the index corresponds to the number of similar factors that you will have to get. The last step is to write the similar factors as one number outside the radical sign, and the other factors, if there are any, will be written inside. The second example is the cube root of 104. Again, for the first method, we have to find the perfect nth factors of the radicand, which are the cube root of 8 and the cube root of 13. Next is to use the product property, then simplify the perfect nth factor, which is 8. This will result to 2 cube root of 13. For the second method, we have to take note of the index, which is 3. We now need to factor out 104 into 26 and 4. 26 can still be factored out to 13 and 2, and 4 into 2 and 2. From factoring the radicand out, we are able to get 3 similar factors. The similar factors will be written outside the radical sign, and the other factors will be written inside, which will give us the same answer as with the first method. The last example consists of both numbers and variables. It is a square root of 63, x raised to 9, and y raised to 4. For the first method, we again get the perfect nth factors of the radicand, which are 9, 7, x raised to 8, x, and y raised to 4. Next is to apply product property and simplify the perfect factors, which are 9, x raised to 8, and y raised to 4, which give us 3 x raised to the 4th and y squared. For this example, we combine 7 and x into one radical expression because both of them cannot be factored out or simplified anymore. The final answer for this example is 3x raised to the 4th y squared square root of 7x. For the second method, we first take note of the index used, which is 2. Then we factor out 63 into 9 and 7 and 9 into 3 and 3. We get two similar factors which we write outside the radical sign and the other factors inside. Next, for the variables. The first is x raised to 9. Since the index is 2, we have to ask ourselves, how many 2's will I get from 9? The answer is 4, but we still need 1 for it to be x raised to 9. We now write x raised to 4 outside of the radical along with 3. The next variable is y raised to 4. Again, we ask ourselves, how many 2's will I get from 4? The answer is 2. Since there is no remainder, we will just write it together with the numbers outside the radical sign.
Now let's proceed with condition 3. This case tells us that the index of a radical is in its lowest possible form. taking 6th root of x squared as our first example. First step is to change the radical expression in exponential form, resulting to x raised to 2 over 6. Using your knowledge in simplifying fractions, we can infer that 2 over 6 is not simplified since it has a GCF of 2. This will lead to our second step, which is to simplify the exponent. This will result to x raised to 1/3. Our third and final step is to change the expression back to a radical expression. So our final answer will be 3rd root of x. Let's take a look at our next example. 9th root of 27, a raised to 6, b raised to 3. Note that 27 can be written as 3 cubed. So our expression will be 9th root of 3 cubed, a raised to 6, and b raised to 3. Applying the first step, this expression will become 3 raised to 3 over 9, a raised to 6 over 9, and b raised to 3 over 9. Simplifying the exponents, we get 3 raised to 1/3, a raised to 2/3, and b raised to 1/3. By transforming it back to a radical expression, we have 3rd root of 3a squared b. For our last example, we have 8th root of 49, c raised to 6, d raised to 10. Notice that the exponent of d is bigger than the index. This shows that we will have a coefficient in our final answer. Note that 49 can be written as 7 squared. By doing our first step, we have 7 raised to 2 over 8, c raised to 6 over 8, and d raised to 10 over 8. And simplifying their exponents will result to 7 raised to 1/4, c raised to 3/4, and d raised to 5/4. Our final answer will be d 4th root of 7 c raised to 3 d.
You have 1 minute to finish each page. Ten seconds left. Time's up! Ten seconds left. Time's up! Ten seconds left. Time's up! If you are done, check your answers with this answer key. How did you do?